Hello everyone, my name is Evalina Vanesia Simanjuntak, with my number student is 42123010066, and I'm from class Mechatronics 5C morning. So in this video, I will explain about my project for the Math Vision Midterm Exam, handwritten letter classification using HOG and SVM. I've looked with leave-one out cross-validation or LLCV. So for the first one, I will explain just a little bit about my program. This program was developed in Python using several key libraries like Pandas, NumPy, Matplotlib, Seaborn, Sketchimage, and Sklearn. Pandas and NumPy for data handling, Matplotlib and Seaborn for visualization, Sketchimage for HOG feature extraction, and Sklearn for building and evaluating the SVM model. At the beginning, I put my identity information like my name, my student number, and my class. And then I define the file path for the dataset amnis.lettertrain.tsv. It's download from Kaggle. And then I load the dataset using pandas.read_csv. The first column represents the labels from 1 to 26, while the remaining columns are the pixel values forming 28 multiple 20 image. And because the amnis images are stored upside down, I create a function called fix_orientation that use np.flipper image.c to flip and transpose each image so it's displayed correctly. This step ensures that the feature extraction letters are accurate. And after that, I perform data sampling, taking 500 samples per class for a total of 13,000 valid samples. This guarantees that each letter from A to Z has the same number of training samples. And then next, I apply HOG feature extraction or histogram of orientation gradients. The parameters I use are pixel per cell is x and x, cell per block to N2. This configuration produces 144 features per image, describing the direction and intensity of edge in the letters. And this process took about 3 seconds for all samples. And then I train a support vector machine or SVM classifier using a linear counter, and with the C is 1.0. SVM is well suited for high-dimensional data like HOG because it finds the best boundary separating different letter classes. And for evaluation, I use leave-one out cross-validation or LLCV. This method runs 13,000 iterations where each sample is tested once while all other samples are used for trainings. The entire evaluation took about 173.88 minutes. It took around almost 3 hours. And then after I complete the entire training and evaluation process, we can see the result in the terminal output. From the terminal output, it can be observed that the model achieved an accuracy of 82.5%, which means the system successfully recognized most handwritten letters with a high degree of accuracy. And beside the accuracy, the program also displays the values of precision, recall, F1 score, and for each letter from A to Z. In this metric provide a more detailed understanding of how well the model performed for its misclassification occurred. And from the letters achieve an F1 score of around 0.96, showing decent performance even though there are still a few misclassifications. Letters such as C, D, E, and F have a F1 score ranging from 0.84 to 0.86, which indicates consistent recognition. And on the other hand, the letter G is one of most challenging to identify, with an F1 score of 0.6444, likely due its visual similarity to letters like C or O. And in contrast, letters such as M, O, P, and S perform very well with scores above 0.88, and the letters that achieve the best result with an F1 score of 0.9485. Overall, the average precision recall and F1 score are approximately 0.825, 825, which align well the overall accuracy. This demonstrated that model performed effectively across most classes with only a few letters posing criteria classification challenges. And after displaying the terminal result, this program automatically generate a confusion matrix heat map using the Seaborn library. This image saved under the name confusion underscore matrix underscore LOCV underscore Evalina.png. In this visualization, each row and column represent the letters from A to Z. The dark blue diagonal line indicates the number of correctly classified samples. The darker the colors, the higher the accuracy for that particularly letter. Conversely, the layer of diagonal cells represent misclassification between visually similar letters. And overall, the confusion matrix shows a strong blue diagonal patterns, which means the model was able to correctly classify most of the letters. Only a few letters show overlaps or error, mostly between those that took alike. And from this result, we can conclude that the combination of HOG and SVM with the selective parameter provide an accurate and reliable handwritten letter classification model. That's all from me. Thank you for watching.